Okay, this is like a bonus video that is helpful in Chapter 7 and in Chapter 5 and in any series parallel circuit. You want to know about voltages with respect to ground. And it's possible, it's very possible that the way that they ask for a voltage is with two designators like this, okay? And we'll talk about that down at the bottom of this video. For this particular discussion, I'm talking about when they label something point A, point B, point C, point E. I don't know what happened to point D. I guess I didn't know my alphabet when I built this up, but there we go. So what is VA? I'm looking at a generic circuit with a 10-volt power supply. It has 4 resistors, 1K, 2K, 3K, 4K. If you solve them out, you will get these voltages. The voltage across each resistor is proportional to its resistance. So the 4K gets 4 volts and the 1K gets a quarter of it, 1 volt. But more important, what I want to talk about is how do you find out what VA is? Because VA is just a point. And when the question comes up like that, the second point is always ground. And this is your ground point for this circuit. So when they ask for VA, they might ask for VAF because the F is missing, but it's implied to be to ground. Now, it's also possible that they ask you for VBC. That's right here. If they ask you that, they're looking for R2's voltage. If you were measuring it with a test equipment, B would be to the red lead and C would be to the black lead. And that's how you would go about hooking up your test equipment to measure something like that. Okay, so what is VA? VA is the power supply. VA is VAF. Always look for the ground path, which means that VB is even a smaller computation. VB would be from here all the way back to ground. So you see there are 3 resistors, 4 volts, 3 volts, and 2 volts. VB is basically V234. Take all the voltages. It's a series path. Add them up. 4, 3, and 2 is 9 volts. And that would be VB. Now, VC takes an even shorter path than VA and VB. VC sits right here at this point and connects through 2 resistors. We basically take those 2 resistors, we add their voltages. That is what VC is equal to. And if somebody asks you for what VE is equal to, you would look at that and see that VE is sitting right here across, one side is across the ground, right here at F. So VE is really VEF, which is really VR4, the 4 volts of the resistor. And that's it. That's what it's about. Now, the last bullet there with the little asterisk says when 2 designations are used like VBC, then, you go looking. You go looking at the circuit. BC is right here. There happens to be 1 resistor there. If there were 2, I would add the voltages, but there's only 1. So VBC is 2 volts. VBC is also VR2, the resistor, right? So that's how you would handle it. Now, VBC has 2 designators, and so if you were trying to measure it in the lab, the red lead would go here to B, and the black lead would go to C. Again, if you're only given one terminal, that's the red. So if they ask for VB, B has a red test lead on it, and the ground point would have the black. Hopefully this helps you with your voltages with respect to ground, voltages with respect to test points, or literal references to VBC, VBD, etc., etc.